Hey guys, today we're going to look at some of these word problems that go along with the content from lesson 1.1. We're going to start with number 20. I just want to do a brief review of fractions. Everybody kind of needs to review that now and then, and so this is a good time to do it at the beginning of the year. And so we don't have a lot of time to spend on it, but I do want to at least touch on it. So they ask us to give our answer with the appropriate unit of measure. So really all they're asking you to do there is in the end. In this case, we're going to have inches on our final answer. But they just want you to subtract those two figures there. If it were just -5 inches minus 2 inches, you would know how to do that. That would be pretty simple. It's those fractions that kind of confuse the so let's go through that problem together. I'm going to just drop the labels. And if we remember our algebra, we've got two negative numbers here that are going to be combined together. We could go through and change our signs so that it looks like that. But if you remember, we talked about in Algebra 1 not needing to do that anymore, to just think about the two numbers as being negative, and we're always combining, so we'd be adding those two together because they have like signs. So just the two whole numbers together. We've got a -5 and a -2, and we can make that a -7. All right, the issue becomes those two fractional parts, the 1/4 and the 2/3. We cannot add those together unless they have like denominators. If you don't quite remember how to find like denominators, you're looking for a product or a number rather, that 4 and 3 are divisible into evenly. So we're looking for a number that 4 and 3 are factors of, is another way to say that. If you can't see it right away, this one's pretty obvious. It's 12 is the lowest common denominator, but you don't have to have the lowest common denominator, because in the end you're going to reduce anyway when you get your final answer. So if at any point you're trying to convert fractions and you can't come up with the lowest, just multiply the two denominators together. You would just multiply that 4 and that 3 together, and that will give you a common denominator. It may not be the lowest one, but it'll give you something you can work with. And then we take that new denominator of 12 and we divide it by the old denominator. So down here we've got 12 divided by 4. That gives us 3. And then we multiply it by that old numerator of 1. So 3 times 1 is 3. That's how I get my new numerator. Do the same thing with 2/3. 12 divided by that denominator of 3 gives me 4. I multiply it by the old numerator of 2, and that gives me 8. So now I have 3 twelfths minus that 8 twelfths. Again, they are negative as well. Okay, we've already recorded that negative sign over here in the final answer. So your final answer is -7 and 11/12. If that confused you, why I put negative signs on those fractional parts, maybe if we look at it like this instead, if we just write out the new fraction, -5 and 3/12, and it was a -2 and 2/3 that we are now calling a -2 and 8/12, then maybe you can see that. So there, everything is negative, -5 and 3/12 minus that 2 and 8/12. Combine those together because they are like signs, and you get -7 and 11/12, and there's no need to reduce. It's in reduced form, but we do need to put a label on. All right, moving on to number 22. We have a car that can travel 25 miles per gallon of gas. How far car travel without multiply those two numbers together. This is a simple problem that you can easily do. However, I want to show you how our unit rates work in this problem, since this is a very simple problem that you could easily do in your head or just with a calculator real quick. But as they get more complicated, I want to show you how you can use your labels on your unit rates to help you know whether you multiply or divide. Sometimes it's not going to be divide. So we have 9 gallons of gas we're starting with, and they have told us that 25 miles. The car will travel 25 miles per 1 gallon of gas. All right, so that's your unit rate, 25 miles per 1 gallon. Remember, unit rate is two numbers set over each other in that fractional form, but they have different labels. They have different units. So miles per gallon. So this is a unit rate, and I can put any number over 1 to make it a fraction, and then we just multiply. So this is why we multiply in this problem. And you'll get 225 miles per 1 gallon. Write it like that. More likely, with just a little slash down here, miles per gallon. We'll do the same thing with number 23. A football team scored 24 of their 28 points from touchdowns. A touchdown is worth 6 points. How many touchdowns did the team score? So out of the 28 points, 24 of those were because of touchdowns. Each touchdown is 6 points. And they want to know how many touchdowns the team scored. You know from that is a simple problem as well, that we're just going to divide 24 by 6 to get 4 touchdowns. So you can easily do that in your head. Again, though, let me show you how those unit rates work with this, because as we get more complicated with these algebra problems, it'll become necessary for you to use the unit rates. So we start out with 24 points because that's the number that were assigned from touchdowns. You have two options here for your unit rate. We know that there are 6 points for every 1 touchdown. Just going to write TD there for touchdown. If you remember from Algebra 1, 6 points over 1 touchdown is the same thing as reversing that. 1 touchdown is 6 points. So we can use the reciprocal of the unit rate at any time. If one is true, the other one has to be true as well. We just read it differently. That first one says 6 points per touchdown. The second one says 1 touchdown for every 6 points. Okay, so what we're looking for is which one's going to help us cancel out our label of points. So if I put this over 1, and I'm always multiplying when I do these unit rates, but you're going to see in a second why it's really division, because we're going to use the second unit rate, 1 touchdown per 6 points, so that when I do my actual math, these labels cancel out and I end up with just touchdowns. So remember, the labels will cancel across the multiplication sign from numerator to denominator, just like your numbers will. So if we go from here and we multiply across, we've got 24 touchdowns divided by 1 times 6, which is 6. We're going to reduce 24 over 6, which is that. There's where the division comes from. And you end up with 4 touchdowns, which is the answer we were looking for. Okay, number 25 is an average problem. Jim runs 1 mile by running 4 laps around the track. The times in seconds for each lap are shown in the table. What is his total mile time in minutes and seconds? And then the second question is, what is his average lap time in seconds? So we need to answer that first question before we can even do the second question. We would need to add up all those seconds for each lap and give the total time in minutes and seconds. So they want you to convert it once you get the seconds added up. Give us the time in seconds here. Once you get those added up, we need to convert that into minutes and whatever remaining seconds are left. The easiest way to do that is just to do some long division. And we know there's 60 seconds in a minute. So if we just do long division, 6 minutes, and we have a remainder of 38. Well, that remainder indicates the seconds left over. So there's your answer for the first one, 6 minutes, 38 seconds. Then they ask, what is his average lap time in seconds? So now we're going to go back to that, and we're just going to find the average lap time. How long? What was his average time per lap? You can see that he was faster in lap 1 than he was in all of the other laps, and he was slowest in lap 3. But we want it just an average. If you took all those numbers together and said this is what he averaged over the 4 for each lap, that's the number we're looking for. This sounds familiar, but an average is just the sum of the numbers, and then you divide that by the number of numbers. Okay, average and mean are the same thing. They specifically use the word mean, average in this problem. Sometimes they'll ask you to find the mean. They're interchangeable. And so we know that the sum of those numbers is 398, and we know that there are 4 numbers because there are 4 laps. 4 numbers that we added together to get 398, and then we divide, and we'll end up with 99.5. Make sure you put your label on, seconds per lap. Okay, we're going to move on to lesson 1.2. On the back, we're going to go through those word problems. Starting with number 23, they ask you to write an expression for the area of the figure and to evaluate the expression for the given values of the variable. So there are 2 things that have to be done here. You need to make sure you read through those directions carefully. The first thing is to write an expression for the area of the figure. And if we're looking at number 23, that we know that that's a rectangle. No, just in general, the formula for a rectangle is length times width. They've given us expressions, algebraic expressions for the length and width. So you can just plug those in. Plug in y squared plus 1 for the length, and then we're going to multiply that by the width. I could put the little sign in there, but I don't actually need it, because setting that 2x right next to the parentheses is the same thing as saying multiplication. So I'm just going to set that next to it right there. Okay, so from there, I'm going to come up with a better expression. This isn't really super usable form. We could use it like this, but we're going to go ahead and use the distributive property. So we've got 2x being multiplied by that binomial. Remember, a binomial is when you have 2 terms. So we've got a y squared term separated out with a plus 1. So every time you have a sign change, that indicates a new term. So we've got 2 terms. That's a binomial, and we're multiplying it by 2x, which is a monomial. 2x is going to be multiplied by that y squared. So we're going to call it 2x y squared. And then I'm going to multiply the 2x by that positive 1. And so I end up with this expression right here, which is really usable in a usable form. So that's the first thing they asked us to do. The second thing they asked us to do is the second sentence here, evaluate the expression for the given values of the variable. Remember, every time you see the word evaluate, it just means find the value of. So we're going to find the value of this expression that we just came up with here for the given values of the variable. And they gave us those right up here. Okay, so we'll just take those numbers, and I'm going to write this expression we came up with, but I'm going to sub in the value for those variables that they gave us. Okay, both of them are 3, so we just end up with 3's in all those parentheses. All right, remembering PEMDAS, which in this problem, it doesn't really matter a whole lot because we're dealing with all positive numbers. But remember for PEMDAS, which is parentheses, exponents, multiplication, division, addition, subtraction. All right, these two are on the same tier, and we'll review that as we come to it. But according to this, we need to take care of the exponent on the 3 before we can move on to the rest of the multiplication. So 2 times 3, 3 squared is 9. I'm going to go ahead and take care of this one right here. And now we've got 3 numbers that just need to be multiplied together. And so that would be 54 plus our 6. It's going to give us 60. We don't have any units here. They didn't give us units for this problem. So we don't need to include that in as a label. Your answer is just 60. We're going to do the same thing with number 24, except we've got a triangle. So we know the formula is 1/2 base times height, or sometimes we just call it base times height divided by 2. It's the same thing. If it's base times height divided by 2, we've just distributed that 1/2 out. Or I'm sorry, not distributed, but multiplied that 1/2 by the b and h. So either way works. This one's a little bit easier to use for this particular problem in this form, so I'm going to go ahead and just keep it the way it is. The base is always what the triangle is sitting on. So the surface that it is sitting on like on the ground, if you were to take that triangle and lay it on the ground, what side is down? So that's what we call base. And then your height is that x cubed, the height of a triangle. And this one, it's just that side length. But if you had a triangle that that looked more like this, your base would be here, and your height, remember, is the one that comes down from the tallest point down perpendicular. That's what this little box here means, perpendicular to the base. That would be your height. In this case, we don't have this section of a triangle right here, so we don't have to worry about it. It's just the x cubed. Okay, so again, I'm going to need to distribute that 1/2 out to the y squared minus y. And when I do that, actually, let's back up and do that a little bit differently. Just erase this part. I think it'll be easier if we just multiply all three of these together. If we multiply the numerators together, so really we've got 1/2 times this parentheses. I could put that over 1 just to make it a little easier to see. And then we're also multiplying it by that x cubed. Okay, I'm just putting those multiplication signs in there so you can see the individual terms there. We're going to multiply all those numerators together. So that will give us 1 times y squared minus y times x cubed. And then that new denominator is 2 times 1 times 1, which would give you 2. All right, we could use it like this, but it would be even more simplified, more usable if we went ahead and distributed that x cubed to that binomial. This is a little bit more complicated because we're dealing with all variables, but it's really the same as number 23. We're just distributing that x cubed goes to the y squared. So x cubed, y squared, and then the x cubed goes to this negative y. So it'll be a minus x cubed y. And all of that over 2. And I'm ordering them in the alphabetical order, just because typically in algebra, that's how you're going to see them. If you had said y squared x cubed, that's not wrong, but usually we put the x in front of the y, just follow ABC order. All right, so this is a very good algebraic expression. So we've answered that first part. Now we need to evaluate, given the values they gave us, that x of 2, the y of 5. So every time I see an x, I'm going to drop that 2 in. Every time I see a y, I'm going to drop a 5 in. Okay, and I really probably should be putting multiplication signs in there, and all that's going to be over 2. So now here we have to go back to PEMDAS again. Parentheses, exponents is the e, so I'm going to take care of that 2 cubed, the 5 squared, 2 cubed again. All right, and now here, according to PEMDAS, I need to do that multiplication that I have there first. So that'll give me 200 minus 40 over 2. Now I can go in, simplify my numerator to 80. Oh, not 80. Sorry. $160 divided by 2. My final answer is 80. Again, no units, so we just circle it like that. Okay, number 25 and 26, we're going to write expressions or functions, as how we talked about in Algebra 1 for these word problems. So let's begin with 25. The photography studio advertises a session with a sitting fee of $8.95 per person. The standard package of pictures costs $29.95. So that means the package itself, no matter how many people you have in it, you need to pay $29.95. That's the standard package of pictures, just to have the sitting fee done, period. For one person or 10, you've got to pay that $29.95. It's a one-time fee. Write an expression, or we could say write a function, that gives the total cost of a session plus the purchase of one standard package. And then you're going to evaluate that expression if a family of 4 purchases the package. So again, we've got a two-part here. It's just like 23 and 24. We have to write the expression first. Right? We have to assign a variable for the number of people. Change. Equal the number of people. Dependent on that is the cost. All right, so we're going to say y equal the final cost. All right, so remember your x's are your independent variables. That's what we plug into the function, and it spits out a y value that is dependent upon whatever the x was that you put in. All right, so if we're calling y the total cost, and we know that we have to pay $29.95, no matter if one person gets their pictures taken or 10, and then we're going to add to that $8.95 per person. So every time you add an extra person in, you have to pay $8.95. Well, that's where my x variable goes. That's going to stand in for the number of people. So this is just your general function. You could have it written like this. You could also have these terms reversed. Okay, a lot of times we see it like this when we have our final forms written out, because this is point slope form. Hopefully that looks a little familiar. Y equals mx plus b. All right, your slope, if you were to graph this, well, I guess we would start with your b is 29.95. That's where it crosses the y-axis. And then your slope is 8.95. So that's over 1. All right, so it's a little weird because it's a decimal, but you could almost think of it as, 9. We'd go up 9 units and to the right 1 to get your second point. And so you could graph this line. They're not asking us to do that, but I wanted to point that out in the hopes that kind of starts to come back to you a little bit. Now we need to evaluate the expression if a family of 4 purchases this package. That means x equals 4. So in the scenario where x equals 4, how much is it going to cost? Right, and then following PEMDAS, I'm not going to spend time going through the actual math of that, but you would end up with $65.75. Okay, and we'll do the same thing on 26. You want to buy either a paperback or a hardcover book as a gift for 5 friends. 5 friends. Paperbacks cost $6.95. Hardcover cost $24.99. Write and simplify an expression for the total amount you spend if X of the books are paperback. And then we'll go to that second part where they ask us to value, but we've got to write the expression first. They've already told us what X needs to equal. X equals the number of paperbacks. And that's important that we remember that. And then we're going to let Y equal the total cost again. That's what they have asked us to do, to write an expression for that, or write a function of the number of paperbacks you can buy and how that affects the total cost. All right, so we know that just in general, let me just write this out in general in words, the total cost is going to equal the cost for the paperback books plus the cost for the hardback. And so if we kind of go into it that way, we can sort of start filling in things in. We know that Y is our total cost. And we know that we're letting X equal the number of paperbacks. And we know a paperback book costs $6.95. So your expression for the paperback is $6.95 times X. we're going to need to add to that the cost of the hardback. We know every time you buy a hardback book, it's $24.99. Now, here's the tricky part, is we can't introduce another variable. We can't introduce a z in here. We need to keep this in terms of just x and y, which means that we need to write the expression for number of hardbacks in terms of the number of paperbacks we buy. This is where the 5 friends at the beginning comes into play. You are buying either a paperback or a hardcover book for each of those 5 friends. So you're buying for 5 friends, 1 book each, so you're only going to be buying 5 books. They haven't told us yet whether you're buying 1 paperback and 4 hardbacks or 2 paperback and 3 hardbacks. That information hasn't been given to us. That's what we're going to determine in the second part. But we do know you're only buying 5 books. So if I'm only buying 5 books and I want to know how many of those were hardback, all I need to do is subtract the number of paperback books I bought. So if I told you I bought 5 books and 1 of them is a paperback, then you would say 5 minus 1. You would know I bought 4 hardbacks, and you would take that 4 and multiply by $24.99 to get the cost for those hardbacks. Okay, so we can't introduce another variable. You have to write it in terms of that x. Hopefully that your memory is being jogged a little bit from Algebra 1 on that concept. All right, so there's your expression. Okay, actually we probably should go ahead and simplify it. They did ask us to write it out simplified. So I'm going to distribute the 24.99 to the 5. That will give me this, and then I'm going to distribute it to the x. All right, now I can combine these two like terms, right? They both have an x variable, so they can be combined. And when I subtract those, they have different signs, so they need to be subtracted. That's what I get. And then your constant doesn't change. That's your y-intercept. Again, here's your y equals mx plus b. Okay, this is y equals mx plus b form. All right, so there's your simplified expression. That's what they asked you to do in the first part. Now they want you to evaluate the expression if 3 of your friends get a paperback. So since x is the number of paperbacks, that means that they're saying evaluated x of 3. So I'm going to drop 3 in for x. When I put all of that into my calculator, I will come out with $70.83. So this is for any scenario. You can use it for any scenario, however many paperbacks you're buying. This one is specific. This answer is specific to how much it's going to cost you if you buy 3 paperback books.